Remote sensing is defined as the science and art of obtaining information about an object, area, or phenomenon through the analysis of data acquired by the sensor that is not in direct contact with the target of investigation. This can be done by use of either recording or real-time sensing devices mounted on aircraft, spacecraft, satellite, bio, or ship. During last 40 years, space travel has been giving humanity new opportunities, not only to peer into the depths of the cosmos, but also to look at the length and breadth of our own world. Remote sensing enables us to acquire information about a phenomenon, object, or surface while at a distance from it. More than just a source of blessing pictures, these sophisticated techniques now allow scientists to understand the Earth in ways we never before dreamt. From 1916 onwards, since the beginning of spaceflight, an ever-growing body of information is being gathered using space-based remote sensing. Agricultural, meteorology, oceanography, ecology, cartography, botany, geomorphology, and geology are just a few of the disciplines which have been transformed by this technology. Some of the most important environmental issues of our time are only becoming understood because of a network of remote sensing devices and data analysis systems. In practice, remote sensing is the stand of collection through the use of a variety of devices for gathering information on a given object or area. The remote sensing is basically a multidisciplinary science which includes a combination of various disciplines such as optics, spectroscopy, photography, computers, electronic and telecommunication, etc. All these techniques are integrated to act as one complete system in itself, known as remote sensing. In the decades to come, remote sensing will be a key tool for making critical decisions affecting the Earth and its resources. In a remote sensing system, number of components work as links, and each one is important for successful operation. They are listed below. Emission of electromagnetic radiation or EMR, transmission of energy from the source of the surface of the Earth, interaction with the atmosphere as well as absorption and scattering, interaction of EMR with the Earth's surface, absorption, reflection and emission, transmission of energy from the surface to the remote sensor, sensor detector data output, data transmission, processing and analysis. Basic components of remote sensing. The sun is the major source of energy, radiation and illumination. At any given moment, our sun is bombarding the earth with a variety of wavelengths of EMR, including visible light, infrared, radio and microwaves. Detection and discrimination of surface features means detecting and recording of radiant energy reflected or emitted by surface. Different features return different amount and kind of energy in different bands of the electromagnetic spectrum incident upon it. This unique property depends on the property of material, surface roughness, angle of incidence, intensity and wavelength of radiant energy. Everything in nature has its own unique distribution of reflected, emitted and observed radiation. Those spectral characteristics, if ingeniously exploited, can be used to distinguish one thing from another or to obtain information about shape, size and other physical and chemical properties. Because the emission and reflection of many different types of EMR can be detected by instruments, they can also be used for remote sensing Thus, to understand remote sensing, it is important to first understand the basic of EMR. Electromagnetic radiation. Electromagnetic radiation is one of the fundamental forms of every in the universe. EMR is a dynamic form of energy that propagates. We have motion at a velocity of light, that is c equal to 3 × 10⁻10 meter per second. Electromagnetic energy radiates in accordance with the basic wave theory. This theory describes the EM energy as traveling in a harmonic sinusoidal fusion at the velocity of light. Another theory known as particle theory offers insight into how electromagnetic energy interacts with matter. It suggests that EMR is composed of many discrete units called photons and quanta. The energy of quantum is electromagnetic spectrum. Electromagnetic energy is the energy source required to transmit information from the target to the sensor. It is a crucial medium that is described as an electromagnetic spectrum. Many of the basic forms of energy in the universe are related as part of the electromagnetic spectrum. On the spectrum, many forms exist that describe energy in a specific region of the electromagnetic spectrum. Those are visible light, radio waves, microwaves, infrared, UV rays, X-rays, and gamma rays. This spectrum is an overview of the continuum of electromagnetic energy from extremely short wavelength to extremely long wavelength. Note that as the wavelength of energy decreases, the frequency increases. These divisions are not absolute and definite. Overlapping may occur. Gamma rays 0.03 nanometers, entirely observed by the Earth atmosphere and not available for remote sensing. X-ray 0.03 to 30 nanometers, entirely observed by the Earth atmosphere and not available for remote sensing. Ultraviolet 0.03 to 0.4 micrometers, wavelengths from 0.03 to 0.3 micrometers, observed by ozone in the Earth atmosphere. Photographic ultraviolet 0.3 to 0.4 micrometers, available for remote sensing the Earth, can be imaged with photographic film. Visible 0.4 to 0.7 micrometers, available for remote sensing the Earth, can be imaged with photographic film. Reflected infrared 0.7 to 3 micrometers, available for remote sensing the Earth. Near infrared 0.7 to 0.9 micrometers, can be imaged with photographic film. Thermal infrared 3.0 to 14 micrometers, available for remote sensing the Earth. This wavelength cannot be captured with photographic film. Instead, sensors are used to image this wavelength band. Microwave or radar 0.1 to 100 centimeters. Longer wavelengths of this band can pass through clouds, fog, and rain. Images using this band can be made with sensors that actively emit microwaves. Radio more than 100 centimeters, not normally based for remote sensing the Earth.